It would be nice. Hi guys, hi Krish. Krish, have they started unit circle?
No, we're still on Unit 2C.
Unit 2C, what is that?
It's about like logs and it's about logs and exponentials and like how to convert between both of them and
But are you not finding it easy?
yeah, it's easy.
Okay.
And
So
we
that,
only have a quiz over it, so no test.
oh, okay. But are you able to use what we are learning here, Krish?
Yeah.
Okay. See, but after logs and exponents, everything is going to be new. Yep. Okay, good to know. So for Dhwani as well, it's the same thing, is it?
Yeah.
Oh, okay. Then we are good. Then I'll go over the periodic phenomena slowly. Parvini, what are you doing, ma, in school?
We have a test over 2.9 to 2.15 tomorrow.
But I did post a nice review. Did you see 2.11 to 2.13?
No.
Okay.
I'll check it out
I
today.
created during the break since low past. Can you check?
Yeah, I'll check it today.
Yeah, but 2.15 I don't think I included, but 2.11 to 2.13 I included questions. I made sure I went over as well the each answer. But can you check?
Yeah.
Sushank, what are you doing in school?
Right now we have our midterm, so we have to, this entire week's just been review for our midterm.
Oh, review for midterm. So you're not moving on to third unit 3.
No, we're on unit 5.
Uh, your unit and my unit is different. Have you
Yeah,
not
our
moved?
units are completely
I
different.
know.
But
So have you
but we're
not
on
moved?
my our unit 5.2, which was inverse functions.
Yeah, I see it. So have you not moved on to sine, cosine, trig functions, graphs? No.
That's like that our teacher told us about that. That's like after winter break. That's like way after. That's like in the middle of second semester for us.
Okay, in this case, right, guys, if you are struggling with any particular topic till that we have covered till date, I'm more than open to cover for a week. Okay, I'm going to start periodic phenomena. I'm going to start sine. Cause see, if we start now, by the time December comes, you'll be very thorough with unit circle. I thought they were starting soon after this break, and I was in a little bit of a hurry last class. Okay, to just get that going, but I'll slow down a little bit, slowly cover unit circle so that you memorize unit circle before it comes to school. So you'll all be way ahead if that's the case. Dhwani, the same thing as Krish, right?
Yeah.
Okay. Is there any topic that you're finding it hard at school, guys? Till what we have covered, I will be able to go over it for sure because we do have time, I feel. There's anything that you want me to go over or give more assignments or anything, let me know. Ashruta, how about you? What happened to you? Sorry, guys. Ashruta, what happened to your switchama?
Okay, so it's actually in January.
Oh my goodness.
Yeah.
Okay.
So
That's
for now till winter break, our last test is 2.13 to 2.15.
Oh, okay. You have a test on that. 2.13 seat. Okay. Hey, 2.13 to 2.15, I already no.
Yeah. Well,
What did I post on? I forgot now.
on Friday we have another test on 2.1 to 2.6, and then on Tuesday we have a test on 2.7 to 2.12.
Okay, so the periodic phenomena is starting only in January for you all, like looks like,
Yeah.
right? Okay, then we can go slow, make the unit circle, get the unit circle thoroughly done. Okay, we'll do that. In the meantime, if you have any questions or anything that you want me to cover, please keep me posted. That will help you a lot as well. That's why I'm saying. Okay, let's go ahead. You're all able to see my screen. Are you able to see my screen, Amma?
Yeah.
Okay, good to know. Okay. Okay. I'm going to go into periodic functions. Okay. Last week I got a head start, but I felt like we rushed through a little bit. I'll go slowly so that way we're all on the same page. Dhwani, Krish, you can let me know if there are topics that are hard there. Is there anything like that on log, exponential functions, or whatever functions?
I mean, like we do like inequalities with logs and exponents. And, like it's not hard. It's just like when one of the logs is a quadratic equation which is not factorable, and then you have to like do the quadratic formula. But like our teacher told
Yes.
us to just ignore the domain restriction for the quadratic formula one.
Yeah, because it becomes difficult, right?
Yeah. So I think other than that, I think it's pretty easy.
Okay, maybe I'll review a little bit on that if you want me to, or I can go over this. I feel, let me see. Okay, we'll go ahead and the last part, let me review some of those. Okay, so coming to periodic phenomena, right? So see, the months of the year follows a periodic phenomena. So what are the functions that pertain to this periodic phenomena? Whatever occurs in a period, like the phases of the moon, tides, high tide and low tides occur, right, every single day. So those are all examples of periodic phenomena practically. Okay, phases of the moon, waning, then waxing. So those are all examples of periodic phenomena. Periodic phenomena are functions, are seen in functions which repeat the same again, you see. So let's see this function. Starting now, our functions are going to look our functions are going to look periodic, literally. Okay, looking at this function, see here. Now if this is considered a periodic function, right? So what is a period? From here to here, the y values undergo, when you see the xy graph, right, the y value have their own values, we don't know. So here it is 0, here it is positive 1, here it is again 0, here it's a negative 1 and again a 0. However, this graph tends to repeat again the same thing from 0 to this, whatever it was, again it repeats, again it repeats. So one cycle of wherever it comes back. See, it starts at 0 and then it comes back at 0. So that is called a period. This period keeps on repeating. So this graph is said to go like this. Again it repeats. So this is the same as this. Makes sense? Now, how to define it? It's the smallest change in x value. The period, this period is the smallest x change in x value. After which the function repeats itself. After which The function values, the y values repeat. Any question here? Any question on the period? Okay. Let's say we can, for in terms of functions, right, we can define it like this. See, this is the smallest change in x value for which it is equal to again f of x. Make sense? Meaning this can be, period can be written this way. See, smallest positive value of k, okay, f of x, for which f of x plus k equal to f of x for all values of x in the domain. Can I move on? Okay, now let's go ahead and try this one. Okay, suppose if we consider this as a periodic function, you should be able to find out period. If you consider this as a periodic function, right, how do I make it repeat itself? This is a v. So here the period of this function is what? 8 units. If we want to repeat it again, I'm going to see here you cannot reflect it actually. So but instead it's going to end here. It ended here. Makes sense. The graph value came to the same point again, the value of 2. However, before that you have 1 unit down, 1 unit up. So this is how you make it repeat, and then go down, go up, and then again make a V. So this is how you, I'm sorry.
Miss Priya,
Yes, ma?
I thought the period was from 1 to 4 because it looks like it's repeating from 4 to 8 again.
I'm sorry. You make sense. This repeats, right? This repeats, right?
Yeah.
Perfectly makes sense. I did not observe that. Makes sense?
Mm-hmm.
Okay. Can I move on?
Yeah.
Okay. Now let's see. Wherever it repeats, you can take it. Okay. How about this? What is the period of this graph? Good observation, Parvini. What is the period of this graph? Let's take one point of the graph. Yeah, I can take, that's hard. How, yeah, I can take this point in the graph, right? Yep. Can I take this point, these 2 points on the graph? What is the period of that graph? Do you want to find and tell me, guys? What is the period of that graph? Can I say this is 9.5 units? Right? This one is 6.5 units. That contributes to how many? 15, 16. 16 units is the period of the graph. Any questions here?
No.
No.
Can I move on from here?
Yeah.
Okay, let's see. Now, okay, let's go ahead and do radians. Starting now, the degrees all will slowly disappear. Measuring angles in degrees will slowly disappear, and we'll start putting them in radians. Okay, so let's say we need, okay, let's draw a coordinate plane. Okay, now what is the standard position? Meaning when considering angles, right? You know angles, we have been measuring them in degrees, but in geometry we did get introduced to the concept of radians. However, let's review that a little bit, okay? So, what is the standard position of an angle? When the vertex, what is angle, this is the vertex, right? Where the two rays merge together. So, vertex coincides with the origin, okay? Vertex coincides with the origin, and one of the rays is the positive x-axis. When you have any angle where the vertex is the origin and one of the rays that make up the angle is the x-axis itself, then you call that as the standard position of the angle. Now, you know this is our positive x-axis, right? This one is called the terminal ray. Okay. Let's say now this angle is 30 degrees. So, you know angles when we go in the anti-clockwise direction, it's always positive. However, the same can be achieved here. Here, this one is a terminal ray, right? This one will be a negative angle 30. Any questions here? So, this is quadrant 1, quadrant 2, quadrant 2, quadrant 3, quadrant 4. Makes sense? Okay, now a
Wait,
negative,
Miss Priya.
Yama,
So they're terminal rays because like they're both
because
like the same angle.
yeah, the terminal ray for any angle you have a terminal ray. Which is the terminal ray? The angle that terminates the angle, literally. See, in this
Okay.
case, this terminates the angle. In this case, this terminated the angle. So this is a terminal ray, this is a terminal ray. Make sense?
Yeah.
You can't call this as a terminal ray because that's a positive x-axis and that only defines the standard position of an angle. Make sense?
Yeah.
It's called the initial ray for that matter. Okay, can I move on?
Yeah.
Okay, now let's look at this. Okay, let me ask you this. Negative 225 degrees comes in which quadrant? Negative, we can make it interactive, guys. Negative 225 degrees comes in which quadrant? Guys, you're going to tell me, guys. I'm not going to. Negative 225 degrees comes in which quadrant? 0 degrees. I have not yet gone to the radians. So this is 180 degrees. This is 270 degrees. Now negative 225 degrees. So this is 0, 90 degrees, minus 180 degrees, minus 270 degrees. So negative 225 degrees comes in which quadrant? Guys, am I with you all?
In the second quadrant?
In the second quadrant. So when you think about it, it goes somewhere here. It's between this and this. Any questions?
No.
So you go clockwise if you want negative angles. You go anti-clockwise if you want positive angles. You have to be thorough with this, and we are slowly going to move out of these degrees and go to radians as well. Okay.
I have a question. Why
Yes,
does the like way you change why does the way you rotate it change why does it make it negative or positive if it like ends up on the same place?
Okay, I'll tell you. It ends up on the same place, but the values become different, right, Amma? Okay. Let's do this. This is 0. This is 90. Okay, now I want to indicate 30 degrees. Okay, meaning these are just conventions which we have agreed to follow. Early on, we set up something and we have agreed to follow that. We have agreed that any anti-clockwise, when we move up, it's going to be 30 degrees. Now, when you think about this, right, this is going to be 330, right? Right? So, minus 330 is the same as 30 degrees. The values are going to be different, right? So, Shank.
Yeah.
Did that answer your question?
Yeah, I got it.
Now let's say we'll talk about another angle, 60. If this is 60 degrees, I can also refer to it as 300, minus 300, right? Make sense? Okay, now suppose if I have an angle like this, this is 30, yes, this is 30, but I can't call this angle as 30. I mean, how do I indicate ray 1 and ray 2? They are different, right? Meaning they are at different positions. If I just say 30 degrees, how will you know that this is your baseline? How will you know this is your baseline? You will never be able to identify, right? Where is ray 1 and ray 2? So, in these cases, it really helps. This is 30 degrees. Then what should be this? 150. Otherwise, you can have it as this one is 360 minus 150. Make sense? Does that make sense? Minus Amma. Make sense? Any questions here?
Wait, Miss Priya,
Hmm.
if that was 150 degrees, then that would be negative 30 degrees, right?
If this was 150 degrees, this is negative 30, you mean?
No, the other one.
Which one, ma? This one?
Yeah.
Wait. You start from here.
Yeah.
Okay. Tell me your question. I didn't get you.
So that way is going positive. So if that is 150 degrees,
This is 150, correct?
I thought that one had to go opposite to the other
Amma,
angle.
draw and show, ma. Let's get it clarified. Draw and show. Dhwani, are you here, Dhwani?
Yeah.
Like since this one is going positive, and I thought this one had to go this way.
Everything, the starting point is this. These are all terminal rays. You get it?
Yeah.
This is like my bus terminus. All the buses come here and stop and start. You got it? Meaning,
Yeah.
an angle cannot start from here. You got it?
Yeah.
Does that make sense? See, this is a terminal ray. So this has to go from here. Again, this is a terminal ray. Again, it goes from here. Okay, if I want this angle, again the starting point has to be my final, this is this line. The x-axis is my starting point, whichever direction I go. Make sense?
Yeah.
From there, if you go up, it's positive. If you go down, it's negative. That's it. Make sense?
Yeah, it makes sense.
Okay. Now let's see this. Let's see this one. Okay, how about this? Okay, this is a very basic exercise. I don't know whether we want to go over this, but let's see. Now, we want all the angles that are in standard position. I'm going to mark the initial and the terminal rays. I'm going to take it slow, as I already told you. So we are thorough with unit circle when we come there. Okay, what are all the angles that are in standard position? I start from this, CDB. Angle CDB. What is the initial ray? CD is my initial ray, DB is my terminal ray. What other angles are in here? CDA. Initial ray is again CD, but the terminal ray this time is DA. Any questions here?
No.
Okay.
Wait, Miss Priya, could you go back? I was
Yes,
copying it down for a second.
absolutely. Wait, I think I erased it. Hold on. How about this? Tell me, Madhuni.
Yeah, I got it. Thanks.
You got it? Okay. Okay. Okay, now we'll see what is radiance. Okay. How do I describe this? Let's see. Let's say we talked about terminal rays and all this stuff, right? Let me go ahead and draw something. I am going to draw a terminal ray. I'm going to write this out as QIT. Okay, so here you all know that this is the initial ray. This is the terminal ray. Okay. Now, I want to draw a circle. Let me draw a circle around it. Okay. Now, when you think about it, let me go ahead and see. This is theta. We are going to start defining radians. Okay. This is a circle of radius r. This is a circle of radius r. Any questions still here? Meaning I'm drawing a circle of radius r. Okay. Theta is just an angle that I have drawn. It intersects the circle at some point. The terminal ray of that angle intersects the circle at some point, let's say T. Okay. Now the radius of the circle, wherever you see, right, is R. Now the arc of the circle, you have heard of the arc of the circle in geometry. The arc of the circle, I can say, since you have come to pre-calc, right, the arc of the circle is subtended by the angle. Meaning here I can say the arc of the circle. Which arc? This arc of the circle. This is the arc of the circle, right? It's a minor arc, less than 180 degrees. So I can say arc of the circle QT is subtended by the angle. Is subtended by angle theta. Any questions here?
What does subtended mean?
A fancy way of saying.
Okay.
Okay. See, this length literally, if you take out that circle, take out the circle of radius, okay, in that circumference, the arc length, I'm calling it S. Let S be your arc length. Yes, ma. Thank you, ma. I really appreciate it. S, if it is the arc length, right? How do I find in this situation? There's a way to find out theta. The angle measure, right? I can write it out as the angle measure theta. I can write it out as the arc length S divided by the radius. Any questions here? Any questions here?
No.
Arc length by, this is quite an important part which we have arrived at, S by R. Make sense?
Yes.
Okay, we will do some problems in this, maybe, but those are all easy if you already understood the formula. Let's see. Suppose in the same diagram, let me try it nicely like this. Let me have a picture pasted there. Suppose if I have this is much better diagram than what I drew. So here, this is S. Think about this as the length, meaning you take a yarn and make a circle. This length of the yarn, right? Let's say that as the arc length, and this is R. You know what? What is this radian? How do I define this radian? At some point, I would want to start defining radians. We know what are degrees. You know degrees. We have always calculated in degrees, the angles, right? But we have to start referring to angles in radians only, and we are slowly going to define what is 1 radian. 1 radian is the angle, this theta angle, when S is equal to R. Why? How did we do this? Let's see. We said theta was S by R. Think about the scenario when S is equal to R. What happens? Theta equal to 1 radian. Any questions here? So how do we define 1 radian? When the radius of the circle, how do we define 1 radian, is equal to the arc length of the circle, then that is 1 radian. Any questions? So how many radians are there? What do you think? How many radians are there?
In the circumference,
Yes.
2 pi.
2 pi. Yes. Have they started teaching you there in school, Akash?
No, I just remember from geometry.
Yes, agree. So when you think about it, let me write it down as well. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. Again, this goes as 360 degrees here, right? However, if I write it in theta, I can write it out as 0. This is pi, right? So this will be pi by 2, half of that. And then this will be 3 pi by, but guys, you have to memorize these. Then this is 2 pi. These all go together. Any questions? Akash, have they started trigonometric functions in school?
No, we're doing binomial theorem.
Oh, okay. That's good.
But we're learning it with summations and stuff. It's not like the
Oh
past case.
yeah, induction, right? Induction. Let me know if you need help on that. You're doing
Okay.
induction, meaning, yeah, you are paving your path to learn induction, but let me know if you need help.
Okay.
Since you have time, I think they're introducing you to inductions. Inductions will help you later. It was a part of, if you said did you want any assignments on that, Akash? Or do you
No,
need
I'm
any
fine.
help on that? Okay. Okay, so how about this? Use the same formula to calculate this, but slowly I want you to get to understand the unit circle so much better. Okay, so we will use the same formula, but I want you to calculate this and see and tell me. Theta is equal to S by R, you know, and 1 radian is defined as when the radius of the circle is equal to the arc subtended by the angle. Okay, now if the angle measure is 1.4 pi radian and the radius of the circle is 2.7, see, when the angle measure is given in radian, right, you can use calculator for this, but the biggest issue that I would see when you start using radians is you will forget to put your calculator in the radian mode, and if you forget, everything goes wrong. You have to put your calculator. If you start working with radians, make sure you go to statistics or mode. I think it's mode button, and then make sure your there's one row degree or radians. Radian should be selected in the calculator. Do that and tell me what is the length of the arc subtended by this angle. Please send, guys. ഇല്ലേ കണ്ണാ?
Miss Priya, could you do this one on the board? I don't really get how to solve it.
Absolutely. Parvini, that is right, but somebody sent it. Parvini, that's right. Sahil has his answer as. Oh, yeah, okay. Dhwani, that feels. Okay, so basically it's just plugging in here. If the angle is 1.4 pi, s is radius of the circle is 2.7. So theta equal to s by r, 1.4 pi equal to s is what we need to find out by 2.7, right? So basically it's just plugging in, Madhvani. 2.7 times 1.4 pi,
I did that. Yeah.
11.875.
Oh, that's it? Because I thought I was supposed to do something else too, like with the radians or
That's
something.
it.
Oh,
That's it.
okay.
It's
Yeah,
just
that's what I
plugging
did.
in.
I
But
thought I
why
was
did
wrong.
Yeah, but why did I bring this in? For you to memorize this basically. So theta equal to s by r.
Okay.
Okay, so that forms the basic of understanding further. Okay, I know it's just plugging in. You guys are good with that. Okay, now let's see this one. You can use calculators. Okay, now let's come to unit radius. We talked about pi, radians, all this stuff, but I want you to understand that a little bit more. Suppose in this circle that we described, right, r value was equal to 1. Suppose in this circle the r value was equal to 1, let's say. I'm going to call that as my unit circle. Why? Because the radius is 1, right? This point, I'm going to call it as P. Okay, I'll mark it as x comma y. A coordinate, meaning if I draw it in a coordinate plane, literally in a coordinate plane, and then I say, hey, this is of radius 1, the circle is called a unit circle. But when you think about it closely, right, see, what is this? This is your x, the vertical displacement is your y. Any question on that? Any question on that? As any question?
Not really.
Okay, now in this unit circle, can I say okay, we know we first said s is equal the theta equal to s by r, we said, right? Now we are saying, hey, let me assume a unit circle. The main topic is unit circle, so the radius became 1, so theta becomes s. What does it mean? Can I say that the radian measure of the angle, okay, in an unit circle, the radian measure of an angle in a unit circle is equal to the length of the subtended arc? Can I say that? Very sophisticated way of telling theta equal to s. So radian measure, the theta value of the angle in a unit circle is the same as that the length of the subtended arc. Make sense? Now, coming to this, you know circumference of a circle is 2 pi r, correct? Now, circumference means it's the full circle, right? Full circle, right? Now, in this unit circle, I'm going to substitute r is equal to 1. So, the circumference make up 2 pi. Do you see it? Now, half of the circumference is pi, quarter of the circumference is pi by 4, and 3/4 of it would be what? Pi plus pi by 2, 3 pi by 2. Any questions? Okay, can I move on? So these are all in radians. These are all in radians. Yes, ma.
I thought that was pi by 2 up there.
Oh, pi by 2 ma. Ayo, yes ma. Sorry ma. It's my bad. I think I told pi by 2, but I wrote pi by 4. Sorry. Can I move on? 0,
Yeah.
pi by 2, pi, 3 pi by 2 says that, see, pi by 2 is a 90-degree angle. Pi by 2 plus pi by 2 plus pi by 2 is 3 pi by 2s. That's how I remember. Can I move on?
Yeah.
Okay. And again, when you think about it, this is 4 pi by 2. What is that? It's 2 pi. Can I move on?
Yeah.
Now, let's see this one. You know what is pi radian? What is the value of that? I forgot to tell you. Okay, how about this? 0. I said this is pi by 2. This is pi. This is 3 pi by 2, correct? Now, what is the value of pi? It's 3.14. Makes sense? You know pi value is 3.14, right? The number pi is 3.14, right? So a quarter revolution would be what? Please remember the decimal values as well. These become important later. 1.57, this is 3.14. Any questions? Decimal values are not that important, but as you move up, there are places that require you to memorize this. Can I move on?
Yeah.
Okay, now let's see this one. Let me ask this. You think you'll be able to take this and do? I don't know. Okay, let's see this one. Okay, how about okay, suppose if I give you an angle of measure 4.3 pi, I want you to tell me. I give you theta equal to 4.3 pi in radians. Which quadrant does it belong to? Which quadrant does it belong to? Think in terms of pi, then it becomes easy. You keep on going. See, you keep on circling like this, circling like this, circling like this. So 4.3 pi, where does it come?
Is that 4.3?
4.3 ma.
Okay, I thought that was a multiplication.
4.3 radians. Yes, that's right. Was it easy? Okay. What is that? 11.87 now? What is it, Akash? I don't get it. Oh, no, no, no. I don't want the decimal value, Akash. I'm asking this angle comes in which quadrant? That angle comes in which quadrant was my question. Siddhi, is it so? Why do you think so, Siddhi? Yeah, that's right, Parvini. Akash, the angle comes in which quadrant? 4.3 pi? Lopa, I want your answer. Sahil would like to see your answer, Sahil. Why quadrant 3, Sushank? Okay, let's go from here. 0, pi by 2. This is pi radians. This is 3 pi by 2. This is 2 pi. Then again, I'm going to add on. If this is 2 pi plus pi by 2 is 5 pi by 2. Then 5 pi by 2 plus another pi by 2 is 6 pi by 2, but it becomes 3 pi. 3 pi, it's just fraction addition. 3 pi by 2 plus pi by 2 will be equal to what? 7 pi by 2. This becomes on the second turn. See, okay, let me go ahead and do this properly. I don't know whether you all understand. One clean time I'll do, then you can do by yourself. So here, this is 0. Now I go to pi by 2. Then I go to pi, 3 pi by 2. Then again when I come back here, it's going to be full turn, right? So it's going to be 2 pi. Now how to calculate the next one? 2 pi, and again I travel 2 pi plus pi by 2. So I add that. When I add that, it's 5 pi by 2. So I can call the same location as 5 pi by 2. Similarly, come back again. Basically, from 2 pi, I'm adding another pi here. So that will become 3 pi. Now, to this, I'm adding another pi, right? To this 5 pi by 2, I'm adding another pi. So what happens? Or to 3 pi, I'm adding pi by 2. When to 3 pi, if I add pi by 2, what will become? 7 pi by 2. So this can be called as these two. This one, this terminal ray stands for these two. Similarly, to 7 pi by 2, if I again add another pi by 2, it's going to be 8 pi by 2, or I can call it 4 pi. You see, so if 4 pi. Now, again when I go, 4 pi gets added with another pi by 2 when I go, move up again. Again, I'm going to move up. It will be 9 pi by 2. Make sense? So, when you think about this, right, it goes on, see, it goes on going in circles. Okay, the more circles you go, the number of pi's are going to increase. So that many circles you have done, but then the terminal ray value, see, it's going to be pi by 2, 5 pi by 2. So see, pi by 2 and 5 pi by 2 share the same terminal ray. But when you think about them, right, there is an integer difference between them. That tells you the number of revolutions it took. Make sense? Does that make sense?
Hey, Miss Priya,
Yeah.
I don't get the revolutions part.
See, first, okay. See, pi by 2 clearly says you were on the first round, right? Now 5 pi by 2, right? You came up again and then got 5 pi by 2. And then again you came up, you got 9 pi by 2. Did you see that? So the terminal ray shared, the same terminal ray can be shared by infinite number of angles. Does that make sense?
Yeah.
They all differ by an integer value when you think about it. They all differ by an integer value. Am I making sense? 5 pi by 2 minus pi by 2 is how much? 5 pi by 2 minus pi by 2 makes up 2 pi. That is, one full circle is the difference between the two. Make sense?
Makes sense.
Similarly, these two, 9 pi by 2 minus pi by 2 is what? 4 pi. Meaning these two angles differed by 2 full revolutions. Make sense? First time
Yes.
when I went, I had pi by 2. And after that, I went one full circle and another one full circle, I landed in 9 pi by 2. So, the same terminal ray can be shared by different angles. And such angles will always differ by an integer value. See, 7 pi by 2, 3 pi by 2. Okay, the difference was one revolution, right? So, let's see, 7 pi by 2 minus 3 pi by 2 is 4 pi by 2. Fraction subtraction. So, this is equal to 2 revolutions, right?
Yeah.
So that's what I'm saying. So when several angles share the same terminal ray, they might their value will differ by an integer value. That is the number of revolutions. That's what I said.
Okay.
Sahil, are you with me?
Yeah.
Okay. Now let's see this one. Okay. I think you all know the right angle, right? Right angle, sine theta, cos theta, tan theta. Do you need me to revise or you're good? If you're good, I can move on. Do you remember this? What is inner right angle, right? Let's see this one. Sine theta equal to opposite by hypotenuse. Do you all remember remember this, guys, or you don't remember this?
I remember.
Okay. Cos theta equal to adjacent by hypotenuse. Tan theta, oh my god. Tan theta equal to opposite by adjacent. Lopa, do you remember this or you forgot this? So basically,
I kind of remember this, yeah.
remember that? Okay. So it is so ca to SOHCAHTOA. This is how you remembered this when you were in geometry. Can I move on? Can I move on? Your video. Okay. Any questions? Okay. Slowly we'll come to harder pieces now. Can I move on from here?
Yeah. Miss Priya,
Yeah, go ahead.
can you give another practice problem like the one before?
Oh, you want the number of to find which quadrant it is?
Yeah.
Sure. Yeah, it will help guide you to find out the quadrants quickly. Okay, 9.4 pi. Which quadrant does it come? That's a good one actually. Which quadrant is 9.4 pi? You get it? Yup, Sushank. Yup, Advik. Dhwani correct. See, if you can start relating, first of all, I want you to really memorize the unit circle before even we leave this class. I don't know whether it's possible, but at least next class it's possible. And then you have to connect that unit circle with the actual graph. That is your basic understanding of trigonometric functions. Can I move on?
Miss Priya, can you check my
That
answer?
is right. Parvini, that's right.
Thank you.
Sahil, did you have the answer? Akash, did you have the answer? Lopa, do you have the answer? Ashruta, do you have the answer? Where is my video?
Miss Priya, I just sent my answer.
Yes, ma'am. Correct. So one nice thing that you can remember is, Sahil, do you have the answer?
Yeah, almost.
Okay. Lopa, where do you say that, ma? This is 0. This is pi radians. Always remember, a half moon is pi radians. Now again when you
Okay,
come
I'm
here,
sorry.
it's 2 pi. Again when you go here, it's 3 pi. Again when you come here, it is 0 to 4, right? And then again you go here, it's 135 here. Again when you come here, it's again 8 pi. Again when you come here, it's what did I do? I missed 6 pi. Again here 7 pi. Again when you come here, it's 8 pi. Then again you come here 9 pi. But I asked you about 9.4 pi,
Oh,
right?
okay.
You see, so it has to be
Mhm.
in this quadrant. Make sense?
I
You got it. Okay, good. Okay. Maybe one more. Let's see. Oh wow. Okay. How about how about give me a minute, guys. Okay. How about 15 by 6 pi? 15 by 6 pi. Which quadrant will it come in?
Miss Priya,
Mm-hmm.
like, what do we do if it's like the middle, like it's in the middle of two quadrants?
Exactly. Exactly, yeah.
Yeah, because 15 divided by 6 is 2.5.
Yeah, I get it. 3, I just, yeah, 2.5 pi. So basically, yeah, 1 second, guys, 1 second. 1 second, please. I'll help Bandwara. So, okay, that's fine. As long as you found out, I'm fine, Amma. Pi by 2, pi. This is 3 pi by 2. See, when you think about it, 5 pi by 2 is a pair of this. 5 pi by 2. The second revolution comes here. Makes sense? So, got it, Dhwani. So, this was your terminal ray.
Can you come up when you're done?
Yeah. Can I move on? Okay. Now, we'll go back to our circle. We'll go back to this. We'll go back to our point P. Okay. Now, we said this was our unit circle, right? Let's try to identify the point P. Point P. Any point in the coordinate plane is indicated by the coordinate point, right? X comma y. Okay, let this be theta. Now I'm going to construct trigonometric ratios. Okay, so what is this? What is this? This horizontal displacement, what is this? What is it, horizontal displacement? How much? What is this? What is that, guys? On the x-axis, what value is in here? X, right? And the y value, what is this value? Based on the point, you can tell me, right?
Why?
Y. So now let me start doing sine theta cos theta on this. This is y. So I'm going to write out my sine theta for this one. Y by r cos theta on this. X by r. We already said it's a unit circle, right? So clearly this was equal to 1, right? Aha, now see here, y became equal to sine theta, x became cos theta. Does that make sense? Can I write instead of this x, can I write cos theta comma sine theta?
Yeah.
Let's take this point. Again, it's some other x and y, but the theta value differs here. Do you see? It's some other x and y, theta value differs. But again, can I say, let's say this theta, I'll call it as theta dash. Can I call this as cos theta dash, comma sine theta dash this point? Let me go ahead and choose some other point which we have not done yet. Let me take this as my angle. Can I call this point as Q? That angle, let me call it as omega. Can I call that as cos omega sine omega? Instead of saying x comma y values are going to be different. But that's where I have my theta dash or the change in the theta value telling that. So for any point on the unit circle, can I call it as cos theta comma sine theta? Make sense? Any
Yeah.
value on the unit circle I will start representing each of the point on the unit circle as cos theta comma sine theta, but the real value depends on the theta, which is the angle subtended by the arc. Make sense?
Yeah.
Okay, so this is how a unit circle will start having several coordinate points within it. Can I go ahead? Just because my R value was equal to 1, you knew trigonometric ratios. So we use that, and we use the basic formula we studied at theta equal to S by R as well. Here, one thing what you noticed here is, when R value was equal to 1, did you also notice that x square plus y square was always equal to 1? Did you realize that this was the circle equation with center 0 origin? This was a circle equation with center as origin, right? Now the radius is 1. X square plus y square were always equal to 1. And that brings us up to an important Pythagorean identity. X square is written as cos square x, cos square theta, right? X is cos x, x is cos theta. So x square I can write it as anywhere on the unit circle, cos square theta plus sin square theta is always equal to 1. That is a very famous identity.
Miss Priya,
Yeah, ma?
I don't get that part.
Okay, you don't get that part. X square plus y square equal to 1, you understood, right?
Not really.
Not really? Okay. Okay. Here, this is a right triangle, right?
Hmm.
Right? The R value, it's a unit circle. R value is equal to 1, right?
Yeah.
By Pythagoras theorem, leg square, sum of the squares of the legs equal to the hypotenuse square, correct?
Yeah.
Now, R was 1. So, can I substitute this equal to 1?
Yeah.
So, that's where I got x square plus y square equal to 1 by using a right triangle within the unit circle.
Okay.
Now, we already know x was sine theta, right?
Cos theta.
Cos theta. Okay, squared. Similarly, y was sine theta. Squared equal to 1. This derives your Pythagorean identity. Cos squared theta plus sin squared theta in a unit circle is always equal to 1. Make sense?
Yes.
Okay, let me show you. I really wanted to show you a video on this. Meaning, I searched out the internet, but yeah, there are some cool videos. Hold on. Let me get that. I prepared it, but I don't have it ready. Hold on. I wanted you to see that video as well. It's so good. When we studied, we did not have it. I was so jealous of you guys when I saw that. I don't know. Oh my gosh, where is it? I think this was the one. Yeah, I think this was the one. Let's see. I don't remember.
Are you struggling in your calculus
guys,
class?
If this is the video, then
Do you have a hard time understanding your instructor?
Videos.
Do you wish there was a simpler way?
Oh no, not really. Hold on, guys. Give me a minute. No. No. 1 second, guys. Let me see. This is not the Pythagorean identity. No. Okay, I don't have it right now, guys. Hold on. I was searching and I was looking at it as well. Hold on. No. Oh, this was the start of. Oh, this one.
Lesson we'll use a decimal.
Yep. I'm sorry, guys. We'll do it later. Okay. I don't have it right now, and I don't want to waste time. Okay. How about this? Can you find the value of sine theta cos theta for this one? Let's see. Based on whatever we have studied, I'll try to find the video, but go ahead and do this one. What is sine theta, cos theta, and tan theta? What is given? You have to find, see, something is given here. Can you use this to find out what is sine theta, cos theta, tan theta? I am going to let you do the work. You have to, okay, let me show maybe once one, and then you can do if you want me to. You want me to try or you want to try?
Can we try?
Basically, the xy point is given. The horizontal displacement, vertical displacement is clearly given. Okay, but you don't know the r value here. You need to find out the hypotenuse using Pythagorean identity. And after that, once you get the sides of the right triangle, you can easily put what is sine theta, cos theta, tan theta. These are not unit circles. It did not mention that these are unit circles. When it is unit circle, things are so easy. But here it is not a unit circle, but you're given the value of the vertical and horizontal displacement xy. Are you able to do, guys? Or if you're stuck, let me know immediately so that I go ahead and work out as well. That's also fine. Akash. What is it, Akash? I didn't get your answer, Akash.
I didn't send mine yet.
Oh. Oh yeah, minus. I don't have the answer. Yep, I think you all got it. Minus 3. Yeah. Yeah, Sahil, one quick note to you, Sahil. You cannot have irrational denominators with solve. Whenever you have answers, you have irrational denominators, you'll have to rationalize it and then only say the answer.
Miss Priya, could you solve this?
Yeah, absolutely, ma'am. Just let me know, that helps me to solve. So, when we think about this, there is a minus 3 comma 1. That is x comma y. That means to arrive at this point, from the origin, oh, I have a black color. Okay, from the origin, my x value is what here? Oh, it's a unit circle. I didn't, wait. Oh, it's not a unit circle. So here, the radius was minus 3 and it is 1. So the y value, so here, at this point, the x and y, I make a right triangle. So the x value is 3 units towards the left. So it was a minus 3 in here and the y value was 1. So this is 1. Make sense? So this is 1. If this is the case, right? Let me redraw that right triangle. Okay, this is 3. But see, this is a minus 3. You have to remember that, okay? So now, let this be the leg Let this be another leg.
Do we have to put -3 or just
Uh,
say it?
I'll tell you where it becomes important when you write out the right now, meaning for doing this Pythagorean identity, it's going to be squared, so there's nothing big about it. Okay, this is square root of 10, so c square is 10. But when you this there's not going to be any change if you put a -3 or +3. That's why I wrote it as 3 units. However, when you write the sine theta, cos theta, tan theta, right, it's going to be much different. Sine theta, then it becomes 1 by root 10. You cannot answer it like this, so you'll have to multiply by root 10. So that becomes root 10 by 10. Number 1. Number 2, cos theta will be -3 by root 10. Again, root 10 by root 10. This will be like this. So for this one, you will have to indicate it with a minus, right, Akash? Again here,
Yeah.
tan theta will be -1 by root. So this will be -1 by 3. Any questions? Any questions here? Can we go ahead?
Yeah.
Let's see, 1 or 2 more questions on this, then we can move on. Okay, maybe one more question on this. Okay, then I want to revise the 30, 60, 90 and 45, 45, 90 triangles this week or next week, whatever it is. Okay, how about this? I have 6 comma 0. I don't know. Okay, let's see this one. Let me change these points. Okay, this is 6 comma 0 and I'm going to change the points. 2.6 comma minus 5.4, 2.6 comma minus 5.4. I'm going to have a point here, 2.6 comma minus 5.4. If I have this, can you tell me this one, I want this big angle. Okay, I'm going to take this angle off. Let me mark it as well so we are clear. Let me mark this angle. I'm going to take this angle now, no thetas. Okay, I'm going to take that angle as alpha till here, till here. Now can you tell me what is sine alpha, cos alpha, tan alpha? Would you be able to do it, you think? I think I feel like there's a lot of details. Yeah, you don't even need to find, you don't even need to apply Pythagorean theorem. Yeah, they gave you a lot of details. Can you find it? Yes, ma. Sure, Lopa. Go ahead.
I can submit this answer and then can I leave, Miss Priya? Thank you.
Oh, that's nice, Advik. Yeah, I think you guys got it. So can you send the answers for this one? I would like to have your answers in decimals. If possible, before you come for next week, if you can by heart your 45, 45, 90 and 30, 60, 90 angles, that will easily get us finish the unit circle next week. If you can just revise what was the 45, 45, 90 angles and 30, 60, 90 angles in geometry, that will completely give us a big picture of unit circle by next week. If you have the answers, I'll let you go, guys. If you don't understand, let me know too.
Miss Priya, I don't understand this.
Yes,
Could you
I'll help
explain
you,
it?
ma. I'll help you. Points. Was it 0.71? I don't know. Yeah. I don't know. Oh, okay, okay. ஒரு நிமிஷம் இருமா சொல்லுங்க. Sin alpha was what is this, guys? Advik, no, Advik, I'm getting different ones. I don't know who's correct now.
Wait, how is the x value 6? I'm confused.
How was the?
X value, isn't the radius 3 already?
Yeah, radius is 6, amma.
But then, oh, should I forget about that -3 1 compound then?
Yeah, you can forget that. You
Okay.
see, that's what I said. This is for earlier.
Okay.
I should have crossed it out. The thing is, if this is 6, right, this value is 6, guys. This value, this radius is 6, right? First mark that down. And then coming to the xy values, right, let me mark that xy. This x, this y, right? Clearly that this y is down, right? Minus 5.4. This x is 2.6. Now this is our alpha. Sin alpha is what? See, that angle is the same as negative of this angle, right? So sin alpha will be equal to opposite by hypotenuse. Cos alpha will be equal to adjacent by hypotenuse. Tan alpha opposite by adjacent. I need to have a calculator to do this. So approximately this is going to be minus 0.9 approximately, because
Miss Priya, is the cosine theta not negative?
Cosine theta, yes, cosine theta is adjacent by hypotenuse. 2.
No, I get that, but you said that the alpha angle would be the opposite of the tinier angle, right? So wouldn't it be negative 2.6 over 6? Since it was negative for the other two?
It is negative for the other two, but the cos theta will be positive. I'll tell you why. Good question, Dhwani. Okay, so let me finish this and I'll tell you why cos theta will become positive. This is 0.433. Let me write it down. This is approximately equal to 0.433. This will be 2 point something. Minus 2 point something. Now when you think about it, right, minus 2.07 something or 007, whatever it is, okay, approximately this is equal to this. Now when you think about it, this, remember, in if this was a unit circle, okay, so theta equal to s by r, right? So now for a unit circle, here it's not a unit circle, I understand, so you substituted 6. In this case, each value, whatever, whether it is a unit circle or not, you remember this was cos theta sin theta. X comma y represented cos theta sin theta, correct? Or cos alpha sin alpha, right? When you think about it, any point in this quadrant will be positive, positive. Any quadrant in this quadrant will be negative, positive. So cos will be negative, sin will be positive. Here any point in this quadrant, right, both will be negative, negative. Any point in this quadrant, right, it would be
Positive, negative.
positive, negative. So the cos theta will be positive, sin theta will be negative. Does that answer your question, Dhwani?
Yeah.
So see, sin is negative, cos is positive.
Miss Priya,
So, Yama,
how did you determine that the hypotenuse was 6?
Because the radius is going to be the same, whether it is here or here or here, the radius is always the same, right? This is given as 6,0, this point, right?
Oh, that's the radius.
Yeah,
Oh,
x
okay.
value is the radius, right? X is the
Yeah,
radius.
yeah,
Yes.
yeah. Okay, I understand.
Yeah. Any other questions for me? Guys,
Miss
getting
Priya,
used to
for the
slowly.
homework, could we have like these sort of problems
Yeah,
for
sure, ma.
practice?
Sure. I'll make sure you have these. Ma, this
Okay.
will give you a nice base for unit circle. Your school will be so unit circle, they will just run like anything. Meaning you won't have time to memorize unit circle. We are going nicely slowly. Take these 3 weeks to by heart the unit circle so well. When they open up, you will be amazed. You will have a good time when January starts. But in the meantime, if you have any other struggling topics, let me know. I'll also cover that.
Okay.
Okay, this I'll post though. I already posted the homework, I think, but I posted extra. I thought I'll cover more. Okay, it's okay. Okay, we have only gone till 3.2. Okay, I'll stop here. I already posted, but I'll give you more if you want. Can I stop here, guys? Okay, have a nice week ahead. See you all next week.
Thank you, Miss Priya.
Bye.
Miss Priya.
Yeah.
Do you know where I could like find more FRQ practices for like? I think our teacher said it was FRQ 2.
What is it? FRQ 2 means?
So for 2.15, I don't have my notes, but there was a bunch of FRQs that she gave us like 2, and I don't feel like I had enough practice with them.
Oh, the FRQ. When is your test, ma?
Tomorrow.
Oh, 1 minute. Iruma. Do you have the previous year's FRQs?
What do you mean?
College boards previous year's FRQs do you have?
I don't think so.
Do you know how to get them?
No.
Interesting lady. Okay. Wait a minute. Past exam FR. See. Oh, 2025 and 24. Ma, teacher will, if they have a test, FRQs will be repeated only from your old questions. See there. I sent you a link. You have 2025-24, correct? Oh, AP Precal came only in 2024. For which unit, ma? For which unit?
The 2.9 to 2.15.
Okay, wait. 2 point?
The
2.9.15.
Yeah.
I'll be down there, okay? Yeah. I'll get ready and I'll just play it for you.
Illa play panna vendam, it's okay. I'm coming, ma. It's a lot you can do. Wait. Did that help you? No?
1 second.
MCQ, FRQ. No, you want FRQ. Wait, FRQ. Progress check FRQB.
I can show you what one of our FRQs looked like if you want.
Sure. It's going to be on logarithms, right?
Yeah, the logarithmics.
See, but
it was this one.
Which one? 3+1 per week. Did you see the 2 practice that I gave you?
The one in Google Classroom? I looked at the review one.
Illamma. Illa. Now I sent you a link. Did you see?
Yeah, I did.
Does it help you? Wait, Anna. Wait, I'll give you more.
Okay.
2.9 to 2.15.
15. She said it was gonna look like exactly like this, but like with, I'm pretty sure, different numbers.
Correct, ma. That is why I'm asking you to do the 2024 and 25 questions. Open that link in the same link that I gave you. The link that I gave you, can you open that?
Yeah.
Open that now. You want the 2023 paper as well. 2024-25, I gave you the link, right?
Yeah.
You have to go to the second question as well. Second question is always from this unit. Do you know that the second question is always from this unit?
I didn't know that.
AP pre-calc.
The 2025 one didn't have any questions like from the one my teacher gave me.
2025
25.
didn't have. See, this one is good, ma. Wait. Model solution A. See, log functions are in here. It'll mirror this one. See here. This one is good. 2020-25 did not have it. You're saying, it has to. It has to have. How come you're saying it doesn't have? Wait, let me see. Because the second question has to mirror that.
Oh.
Wait, let me see. Wait, after the same. Yeah, it has. I know what has happened. 30 minutes. F inverse. Okay, you don't have it. Right now I sent you link. See that? But wait, I'm also getting you more. Wait. Hey, but I don't want you to give this unless I check. Oh, Unit 2 progress check B. Oh, I see. One minute, ma.
Okay.
Unit 2 progress check B. Unit 2 FRQ part A. That I don't want to. Unit 2 progress check B from College Board has it. Wait, amma.
Okay.
Unit 2. Oh, FRQ. Okay. You have limits, huh?
Yeah.
ஐயோ இது calculus கிடையாது AP pre-calc. Okay. AP pre-calc. Unit 2 progress check with AP classroom Unit 2. No. Hey, I need some time. You always bring me so late, you know.
I'm so sorry. Usually she gives us a test review and all, but like she just made us like do some practices in the class. So like I didn't expect her to not give us a review. I can just go over like the notes and the previous ones that we.
No, wait. Oh yeah, this is a good one. Oh, this is a good one. Did you see this? Did you see this Quizlet? You're noting down all the links that I'm giving, huh?
Yeah, I'm saving them on
The third link, Quizlet link, can you check? This is AP pre-calc. Yeah, this is what I want, but I'm not able to get this. Exactly, this is what I want. Wait. I should be able to get it, ma. Wait, amma. என்னடா yeah ஒரு few minutes இருமா வரேம்மா. She has a test tomorrow. 1 second. Can I send it to you, ma?